Hello everyone, I am Vaishnavi and my team member is Himaja and we are from cybersecurity and our concept is deadlock detection and we done this presentation under the guidance of Dr. M. Prasad, Associate Professor in Department of CSC. In this presentation, the concepts we are going to cover are the need for deadlock detection and the categories of deadlock detection techniques. Process in operating system uses resources in the following way. Request a resource, use the resource, releases the resource. A deadlock is a situation where a set of processes are blocked because each process is holding a resource and waiting for another resource acquired by some other process. Consider an example. When two trains are coming towards each other on the same track and there is only one track, none of the trains can move once they are in front of each other. A similar situation occurs in operating systems. When there are two or more processes that hold some resources and wait for resources held by others, the processes are effectively stuck and cannot make any progress. It is a serious issue in operating systems as it can cause the entire system to freeze or crash. Therefore, detecting and resolving deadlock is crucial for smooth operation of any computer. Deadlock detection is a technique used in operating system to identify and resolve deadlock situation. For example, in the below diagram, process 1 is holding resource 1 and waiting for resource 2, which is acquired by process 2, and process 2 is waiting for resource 1, which is causing the deadlock situation. Need for detecting deadlock is it prevents system from hanging, it handles errors, uses for resource sharing, makes complex workflows, resource recovery, fault tolerance, and allocates resources dynamically, efficiently, and use it to share resources. Already known about the cons of deadlock. Thus, in order to get rid of deadlocks, operating system periodically checks the system for any deadlock. Now, the main task of operating system is to detect the deadlocks by corresponding detection technique based on the instances of resources. If it is single instance, we apply wait for graph. It is multi-instance, then we use safety algorithm. Let us look into the resources that have a single instance. In this case of deadlock detection, we can run an algorithm to check for the cycle in the resource allocation graph. The presence of a cycle in the graph is a sufficient condition for deadlock. In the below diagram, resource 1 and resource 2 have single instances and there is a cycle, so deadlock is confirmed. Let us have a look into wait for graph algorithm. The wait for graph algorithm is a deadlock detection algorithm used to detect deadlocks in a system where resources can have single instances. The algorithm works by constructing a wait for graph, which is a directed graph that represents the dependencies between processes and resources. Already discussed about the wait for graph. It is used for the resources that are having a single instance. Here, figure A shows the resource allocation graph and figure B shows the wait for graph of the corresponding resource allocation graph. A wait for graph can be constructed from a resource allocation graph by eliminating the resources and collapsing the associated edges as shown in the figure below. An arc from Pi to Pj in a wait for graph indicates that process Pi is waiting for a resource that process Pj is currently holding. As before, a deadlock exists in the system if and only if the wait for graph contains a cycle. To detect deadlocks, the system needs to maintain the wait for graph and periodically to invoke an algorithm that searches for a cycle in the graph. An algorithm to detect a cycle in graph requires an order of n square operation where n is the number of vertices in the graph. Now let's look into a condition where there are multiple instances of resources.
The wait for graph scheme is not applicable to a resource allocation system with multiple instances of each resource type. The deadlock detection algorithm that we described next is applicable. The algorithm employs several times varying data structures that are similar to those used in Banker's algorithm. Banker's algorithm, which looks at each process available resources within its resource allocation graph RAG to determine if any process has more than one instance of any given resource type. The Banker's algorithm is a classic deadlock detection and avoidance algorithm used to manage resources and prevent deadlock in a multi-process system. We shall treat the rows in the matrices allocation and request as vectors and shall refer to them as allocation and request respectively. The detection algorithm described here simply investigates every possible allocation sequence for the process that remains to be completed. The algorithm works by carefully tracking resource allocation, resource requests, and resource release to ensure that process can safely request and release resources without causing deadlock. As we have discussed, the banker's algorithm has available maximum allocation need. Now let's take an example to work out this. To this, we consider a system with 5 processes and 3 resource types ABC. Resource type A has 7 instances, resource type B has 2 instances, and resource type C has 6 instances. Suppose that at time t0 we have the following resource allocation states as given. We claim that the system is not in deadlock state. Indeed, if we execute our algorithm, we will find that the sequence P0, P2, P3, P1, P4 will execute in finish of I equals to true for all I. By following the above steps, we conclude that the example has no deadlock as we have obtained all true vectors in it. We have come to an end of the deadlock detection, and this is presented by Himaja and Vaishnavi of 2nd CS. Thank you.